Hi guys, this is Vineet and I welcome you to this video. Today's video topic is managing unique and check constraints in SQL Server. And this video includes 20 demos, which is towards the end of this video. So the demos will be starting somewhere near after like 10 minutes of theory discussion. So if you want, you can skip out to demos directly if you don't want to listen to theory. Otherwise, what we would suggest is that you should listen to theory part of this video as well to gain better understanding of what the unique and check constraints are. So before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. Let me give you 5 seconds. Please go ahead and subscribe right away. I'm waiting, guys. Please go ahead and subscribe. So, guys, I hope you must have subscribed by now to my channel. So, let's come back to today's topic, which is managing a unique and check constraints in SQL Server. Let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. If it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our video, so please do post in your comments, feedback and suggestions. We eagerly wait for your comments and would love to read the same. However, guys, I've seen that not many of the people post comments to us. We really like you to post comments on our videos because it gives us an encouragement after reading your nice comments. And yeah, definitely, we also consider the negative feedback and the suggestions given regarding our videos. So please do post in your comments. We would like to hear your thoughts regarding our videos. And if you need some improvement in the videos, then yeah, definitely let us know about that. So let's move ahead. So guys, we have created some playlists for you to watch. If we talk about this video pertains to the SQL Server database design category and SQL Server tables category. Some of our major playlists are SQL Server database design, tables, business continuity, indexes, performance tuning, integration services, and Transact-SQL. If we talk about the total number of videos posted on our channel, it's more than 259 videos at present. This will be, I think, the video number 260, which I am posting right away. So the reason we create playlist for you is because we feel that playlists are best way to learn. For example, if you want to learn about the SQL Server database design area, what we would recommend is go to the SQL Server database design playlist and watch out all the videos from starting till the end to gain better clarity in that area. And apart from this playlist, though I've included all the links for all these playlists in the video description area of this video, I also have a channel page link, which I'm also including in the video description area. So you can check out my channel page as well. And guys, soon I will be starting workshops on SQL Server, where there will be total practical content and exercises which you can work upon. So that I will start doing once I reach the 1000 subscribers mark. So please do subscribe to our channel so that I should quickly reach that mark so that I can roll out those workshops for you. All right, let's come back to today's topic, which is managing unique and check constraints in SQL Server. So let me take you to a little bit of theory. So there will be a little bit of theory, and after that, we will have like 20 demos, to be exact, 22 demos, if I would say. So let me take you through this theory quickly. And if you want to skip to the practical session or demo classes, you can scroll through this video. Maybe the theory part will take 10 to 15 minutes to complete, and after that I will start on demos. So you can skip to that area of the video where we are discussing on demos if you just want to take a look at the practicals. And let me start with today's session. theory session. So we are discussing on managing the unique and check constraints. So unique and check constraints are two type of constraints that can be used to enforce the data integrity. So these two constraints, the unique constraints and the unique constraints and the check constraints, these are the two constraints which can be used to enforce the data integrity in SQL Server. Otherwise, the other ways to impose the data integrity is through primary keys as well, and foreign keys enforce the referential integrity. Alright, so I'm back and let's talk about unique constraints now. So constraints are basically rules. If we say what are constraints, these are rules that the SQL Server database engine enforces for you. For example, you can use the unique constraints to make sure that no duplicate values are entered in specific columns. So the role of unique constraint is basically to make sure that no duplicate values are entered in specific column. So that's the purpose of unique constraint. It makes sure that no duplicate values are entered in any specific columns that don't participate in the primary key. So primary key columns do not have any duplicate values, and if there are any columns which are not participating as a part of primary key, we can define unique constraints on those columns, and basically unique constraint ensure that there are no duplicate values in those columns other than the primary key column. And although both the unique constraints and the primary key constraint enforce uniqueness, so the purpose of both the unique constraint and the primary key constraint is to enforce the uniqueness. So this is their purpose. Use a unique constraint instead of primary key constraint when you want to enforce the uniqueness of a column or combination of columns that isn't a part of primary key. So any of the columns which we are not taking as a part of primary key, on those columns we can definitely apply the unique constraint instead of primary key, because we have already defined primary key for certain columns and rest of the columns that are remaining, and if we want the values in that columns to be unique, then yeah, we can definitely apply unique constraint to that column. Now, unlike the primary key constraints, unique constraints allow for the value null. So if we talk about the primary key constraint, if it is applied on a column, that column cannot contain the null values, because we specifically specify the not null clause whenever we are defining a primary key on the table. Whereas for unique constraints, it allows for the value null. However, as with the value participating in the unique constraint, only one null value is allowed per column. So though the unique constraints are allowing for the null values, however, it can only allow one null value per column. So even though the unique constraints allow the null value, only allow one null value per column. And a unique constant can be referenced by a foreign key constant. That's also another point. A foreign key can refer to a unique constant instead of primary key as well. So yeah, we can pair of foreign keys with the unique key columns or unique constant columns. Now, whenever a unique constant is added to an existing column or columns or multiple columns in a table, by default, the database engine examines the existing data in the columns to make sure all the values are unique. So this is the default check that the database engine performs. It checks for the uniqueness of the existing data. So it checks the existing data for uniqueness. It basically makes sure that all the values are unique whenever we add a unique constant to a particular column. It checks for the existing data for its uniqueness. And if a unique constant is added to a column that has duplicate values, so in case we are applying a unique constant to a column that already has a duplicate values, the database engine returns an error. Alright, and does not add the constant. So it will not be able to add a constant on a column which already has duplicate values. Now the database engine automatically creates a unique index. So whenever we apply a unique constant on a particular column, the database engine automatically creates a unique index in the background to enforce the uniqueness requirement of a unique constraint. So guys, if you don't know what a unique index is, you can watch out my videos on indexes. Please check out the indexing playlist which I've included in the video description area. The link is there for the SQL Server indexing playlist. Under that playlist, you can find out what the unique index is. Basically, this index enforces the uniqueness on a particular column. Now, therefore, if an attempt to insert a duplicate row is made, the database engine returns an error message that states that unique constraint was violated. So, if a unique constraint is defined on a particular column and if we try to insert a duplicate value in that particular column, the database engine will automatically return an error message stating that unique constraint was violated and it does not insert that particular row and it does not add the particular row to a table. And unless a clustered index is specifically defined while defining the unique constraint, by default a non-cluster index is created. So if you want to create a cluster index for a unique constraint, you need to specifically or explicitly specify that. Otherwise, if you go by default, a non-cluster index will get created in the background, all right, to enforce the unique constraint. Let's move ahead. Now unique constraint section is completed and let's move on to the check constraints. Now as unique constraint, make sure that there are no duplicate values in a particular column. So it enforces basically the data integrity. Now the role of check constraint is to enforce the domain integrity, and it enforces the domain integrity by limiting the values that can be accepted by one or more columns. All right. So it limits the values that can be accepted by one or more columns. We define certain kind of rules on a particular column that a particular column should accept only a value within a certain range on a basis of certain conditions. Now you can create a check constraint with any logical expression that returns true or false based on the logical operators. So basically check operators or check constraint use the Boolean expression or logical expression, the result of which would be true or false based on the logical operators being used. For example, the range of values for a salary column. So here we are taking an example of a salary column. So the range of the salary column can be limited by creating a check constraint that allows for only data that ranges from 15,000 through 1 lakh. Now, if we define such a check constraint that the salary column can contain values between the 15,000 and 1 lakh mark, this prevents salary from being entered beyond a regular salary range. So we can, if we define such a check constraint, where a salary could be between 15,000 to 1 lakh, then yeah, we cannot add any values beyond that boundaries, the lower bound and the upper bound. The logical expression for this check constraint would be salary should be greater than or equal to 15,000 and salary should be less than or equal to 100,000 or 1 lakh. Now you can apply multiple check constraint to a single column. So if we talk about a single column, we can apply multiple check constraint on a single column. And you can also apply a single check constraint to a multiple column as well by creating it at a table level instead of a column level. So guys, we can create check constraints at table level as well instead of just at the column level. And if a check constraint is created at the table level, we can apply that check constraint to multiple columns as well. And for a single column, we can apply multiple check constraint on it as well. And let's take an example. A multi-column check constraint could be used to confirm that any row within the country region column value of USA also has a 2-character value in the state column. So this type of constraints can be defined at the table level where there's a need to check multiple columns. Now this allows for multiple conditions to be checked in one location. The benefit of using the check constraints at table level is that it allows for multiple conditions to be checked in one location. Now check constraints are similar to the foreign key constraint. So we are comparing it with the foreign key constraint. So they are similar in some sense. The sense in that they control the values that are put in a column. So foreign keys also control what values can be put in a particular column of a foreign key table. Check constraint also ensures that what values can be put in a particular column. However, there is a difference in how they determine which values are valid. So if we talk about the foreign keys constraints, they obtain a list of valid values from another table, which is a primary key table. So if we just talk about foreign keys, they get a list of valid values from another table. Whereas if we talk about the check constraint, it determines the list of valid values from the logical expression that we define as a part of check constraint. So there's a little bit difference, right? Now there's a word of caution. So constraints that include implicit or explicit data type conversions might cause certain operators to fail. So in order to avoid this, please restrain from doing the conversion in the constraint definition. So we should not be doing any type of conversion while defining the constraints. Now let's discuss on some of the limitations of the check constraints. So check constraint reject values that evaluate to false. So any values that evaluate to false as a result of logical expression. Check constraint simply rejects those values. And because if we talk about the null value, it evaluates to unknown instead of false. The presence in the expression might override the constraint. So for null values, sometimes check constraints can be overridden as well. For example, suppose you place a constraint on an integer column, my column, specifying that this my column, which is an integer column, can only contain a value 10. And if you insert a null value into that column, the database engine inserts null and does not return any error. So the null values overrides these check constraints because those cannot be compared with any of the Boolean results which are true or false. Now a check constraint returns true when the condition it is checking isn't false for any of the row in table. So if check constraint is checking a condition which is not false for any of the row in the table, the check constraint will return true. A check constraint works at the row level, and if a table that was created does not have any rows, a check constraint on this table is considered valid. So in order for check constraint to work effectively, there should be a data in the table. If there is no data in a particular table, any check constraint on that particular table is considered as valid. This situation can produce unexpected result as the following example. So let me take you through a code script discussion for this above fact, this fact which I've just discussed. So let me discuss a code. Let me invoke the SQL Server and I will write out some code for you. Okay guys, SQL Server is up. Let me connect to a default instance of SQL Server and I will work with the my AdventureWorks database. In your system, it will be by the name AdventureWorks 2022. Let me trigger a new query against it. So what I will do here is I will create a table, provide a create table statement. The table name would be check table. I'm taking as table name, and this table contains two columns. So I'm defining column 1, which is of integer type, and a column 2, which is also of integer type. So this table contains the two columns, and this is the definition I'm ending with the semicolon. Right, so table definition is done. Now I'm creating a function using the create function statement. So we haven't covered functions yet, guys. I will create a separate series on functions. So stay in tune. Please subscribe if you have not subscribed. There's a subscribe button below this video. Please use that. Now create function. Let me name it as check function, check funct, and I'm not providing any arguments. And let's define the body of the function. So this function basically returns the integer value, and let's define the body as begin between the begin and end. Now let's define the body of this function. So I'm declaring a variable inside this function where I'm taking a retry value as a variable of integer type, and let's run a select statement inside this function where I'm setting the retrieval variable to count star, and I'm taking the counts from check table, which currently does not contain any rows because just after creation of table it does not contain any rows. So I'm taking a count which will be 0, so the ret value will be 0 on the first initial attempt of this function. Now there should be a semicolon here. So your statements in a function should be separated by a semicolon, not by a comma. Provided a semicolon here, and this statement is completed, so I've provided a semicolon here as well. And in the end, this function is returning an integer value. So let me return the value of retval. which is 0, right? Because count star, I don't know whether it will give 0 or whether it will give null. We can check on that as well. Let's put another code where I'm altering this table, check table, and I'm adding a constraint. The name of the constraint is check row count. And this is a check type of constraint, and let me specify a criteria for checking. So I'm checking that DBO, I'm invoking the function I've specified above. So that is check function. So I'm checking that the result of check function should be greater than equal to 1, but that should not be true in this case, right? And let me specify go after that. So there's done and go. All right, so I've defined a check constraint where it will check whether the value of the function is greater than equal to 1. Now, let me first create a table. I've created this table. So now if I do a select count star from check table, let's see what value do we get usually. So we got the 0 value. So this function will return 0 value, right? If I define that function. Now, the check constraint being added here specifies that there must be at least one row in a table, check table, right? However, because there are no rows in a table against which to check the condition of this constraint, the alter table statement will succeed. So we will be able to add this constraint, although we do not have any rows in the table. So what I'm discussing. So let me create this function quickly. So this function is created. Now let's discuss on this. From this statement, we are altering a table and we are adding a constraint where we are defining a check constraint to execute a function and check whether the table has greater than equal to one value. So only in that case, that check constraint can be defined on the table, but the table has no, even though the table has no rows, we will be able to create this constraint. So the check constraint being added specifies that there must be at least one row in a table. So if we just talk about this statement, this constraint being added specifies that there must be at least one row in the table, check table. And however, there are no rows in the table against which to check the condition of this constraint. The alter table statement will succeed. So let me execute. This statement will succeed, even though there are no rows in the table. This is what that was demonstrated or indicated by this fact. So if there are no rows in the table, right, the check constraint will return true. If the condition is not false for any number of rows in the table. So there are no rows in the table, so check constraint condition will not be checked because it works row wise. All right. Next, let's come to next point, which is check constraint aren't validated during the delete statement. So that's another point. Therefore, executing delete statement on tables with certain type of check constraint might produce unexpected results. So let me discuss this through the this fact through the coding. Let me take you through the code again. Now the check constraint is defined on the table where it checks that the number of rows should be greater than equal to 1. Now I'm inserting certain, so the constraints are checked whenever we insert and update data in the table. Now I'm inserting into the check table. I'm putting some values. So this is the first row I'm inserting, right? So let's insert the row. Now, so we need to provide the values clause over here. All right, so we are inserting a value into check table. Now there is only one row in the table. So if I do select star from check table, all right, and execute it. Now, if we delete this one row from this particular table, ideally it violates the check constraint because the check constraint expect at least one row to be present in the table. But check constraints are not validated during the delete statement. So if I try to delete this particular row, check constraint will not validate the delete statement. So therefore, executing delete statements on tables with certain type of check constraint might produce unexpected results. So if I try to delete this row from the check table, I can specify the criteria where column 1 equals to 10. So if I execute this statement, it will basically remove all the rows from the table, which will violate the check constraint, but check constraint will not get validated during the delete statement. So this statement will execute fine and check constraint will not raise any exception. All right. So I will be able to delete the row from the table. All right. So this is the second place where check constraint aren't validated. That is during the delete operations. So this demo is also done. So let me take you through some series of demos. So this will be a demo class where I will be covering 20 demos in a single stretch. So let me first take you through the demo 1 and 2 where I will create a unique constraint using the SQL Server Management Studio and the Transact-SQL statements. All right, let's go to SQL Server. Let me close this. This example is done. And you can create unique constraints in SQL Server by using the SQL Server Management Studio and Transact-SQL to ensure no duplicate values are entered in specific columns that don't participate in a primary key. Now, creating a unique constraint automatically creates a corresponding unique index in the background, which will be a non-cluster index by default. Now, SQL Server Management Studio is open. Let me take you through demo 1. Now, in this demo, we will create a unique constraint using the SQL Server Management Studio. So let me show you the way how to do that. So right now I've just created a table. What was the table name? Let me check. So I've created a check table, right? So this table has 2 columns, right? And basically you need to go to the table to which you want to add the unique constraint. So for example, if you want the value in the column 2 should be unique, so we can add a unique constraint to this column 2. All right. And so what you need to do is you need to right click on the table to which you want to add the unique constraint and go into the design view. And on the table designer menu, so there's a table designer menu, select the index keys and there are no constraints defined. So I need to add one constraint. So add the constraint. So by default, it has added this constraint IX check table. In the grid under general, so on the right hand side, once we select this constraint, on the right hand side, there's a grid and there's a general section under that. So under the general section, select type. So type is index here. So we need to change the type. So for type, I need to use the unique key if I'm creating a unique constraint. So we need to select a unique key from the drop down list box to the right of the property and basically make it a unique constraint, just like unique key here. Now we need to click on the close button, close the table structure and save the table. So a unique constraint will get created on this particular column, column 2. I hope so. I've created on column 2. Let me just refresh it. So right now I've just created the unique constraint. Let me again go into the design view. I'm not sure on which column it is created. So let's go to index keys. So it is created on column 1. So if you wanted to create on column 2, I need to change it to column 2 here. So sorting order will be ascending order. Unique key is now will be created on. I'm modifying this constraint so that unique key should be created on column 2. Let's do that and close it and save the definition. Now the unique key is on this IX underscore check table, which is a unique key. It's now created on column 2. All right. So this is how you add a unique constraint using the SQL Server Management Studio. Now let me show you how you can perform the same item using the Transact-SQL statement. So let's ignore this table. Let's trigger a new query. So in this query, we will create a new table altogether. So we will be using the AdventureWorks 2022 database to create this new table. And we will create a constraint as well during the table definition. So let me write a code to create a, so this is demo 2 basically, where we are creating a unique constraint using the Transact-SQL statement. So let me quickly show you how you can do that. Let's use a create table statement. So here I'm creating a brand new table. The table name, this will be under the production schema. Table name will be transaction. history archive 4. This is the table name I'm taking, and let's define the give the table definition over here. So the table contains the transaction ID column, which will be of integer type and not null. All right. And second column, I'm just taking one column here, and now I'm adding a constraint to this table. I'm adding a constraint. Let's give this name AK underscore transaction ID will be the name of this constraint, and we need to specify what type of constraint it is. So I'm specifying it as unique constraint, and I need to specify the column on which to create this constraint. So let's create it on transaction ID column. So this is how you define a constraint while creating a new table. So if I execute the statement, a constraint will get created on this table, and the table will also get created. Let's execute this statement. Now, if I go to the table section, let's refresh the table section to see if we have this table. So table name is production dot transaction history archive 4 is the table. Let's expand that. There's only a transaction ID column, and if we take a look at keys, we have this key AK underscore transaction ID, which basically is enforcing a unique constraint on the transaction ID column. Now let me take you through next demo. The next demo is create a unique constraint on an existing table. So in the previous case, there was no table, but in the new case, we are creating a unique constraint on an already existing table using T-SQL. Now let me show you how you can do that through a code. So we have a table called person.password, right? So it has certain columns, and let's see what keys are there. So there's a primary key defined on the business entity ID column, and there's a foreign key as well, which is connecting the business entity ID with the certain column. All right, so we will be creating a unique constraint on the password hash column, right? And the password salt column, combination of password hash and password salt. So let's use this table. Let's add a constraint. All right. So in this demo, we are using an existing table, person.password. So I need to alter this table if I want to add a constraint to this table. So use the alter table statement. Give the name of the table, which is person.password is the table name. And we need to add a constraint to this table, right? So adding a constraint, let's give the constraint name as AK underscore password will be the constraint name, and this will be a unique constraint. Let's specify unique keyword, and I need to specify the columns on which to the combination of columns on which I have to specify the unique constraint. So the columns are password hash and password salt. Let's use these two columns. So this is how you add the constraint on an already existing table. So this constraint does not exist. Let me execute it. Now constraint is created. I can verify it by refreshing the key section. So we have this constraint created on these two columns, and I refresh the columns as well. So columns does not indicate anything, but yeah, we have a key in the background under the key section, which basically specifies a unique constraint on the that will get triggered once the row is inserted or updated in this table. This will get triggered, and it will check the combination of password hash and password salt, and that combination should be unique, and there should be no duplicate entries. All right, we have already shown you how you can add a unique constraint on the while creating the new table. We have already discussed that. So next demo is not applicable here. Create a unique constraint on a new table, because we have already discussed that. We had created a production dot transaction history archive table earlier, so that covers that demo. So I need to move to the new demo, which is basically creating a unique constraint on a nullable column using the Transact-SQL. Now let's go to the SQL server. Let's close this window. I don't want to save this query, and let's trigger a new query. So in this demo, I will use an existing table. Let's see which one we can use. So we have this table AW build version on which we can work. So basically we are creating a unique constraint, and this table, if we take a look at columns, we have the database version column. We can create a constraint unique index on this column. Let's see if this table has any rows. Yeah, it has one row. We have values in the database version column. which is indicating the version of the database. We can create a unique constraint on a nullable column. So this column is here every column is indicated as not null. So the name of the demo should be not nullable column because any of the columns in this example are not null. Let's create a unique constraint on this not nullable column, which is database version. So let me write some code. So the another way to create the unique constraint is instead of using the add constraint statement, what you can do is you can also use the create unique index statement to enforce the uniqueness of that particular column. We can also create a unique index on that particular column. So let's name this index as UQ underscore adventure works build version, I would say. Maybe let me short it down. AW build version, I would say. All right, so this is the index name, and I'm creating it on the table dbo dot aw build version is the table name, and let's specify it on the db version database version column. So let me specify the name of the column database version. So this is the column name where we want to specify this index, and I can take a condition where the DB version is not null, where the database version is not null. I need to take that column within the brackets. So database version is not null. So this is the index we are creating. We are creating index on the database version column. And we are basically checking, we are creating a unique index though, so that the values of this column should be unique. And we are, while creating the index, we are creating a condition. This is a filtered index in some sense as well. Although it's a unique index, it's also filtered. We are only creating it for the rows where the database version is not null. So let's execute it. So an index is created over here under the keys. So I've just created this. So it is not showing to me though. So the index is, so I'm checking it under keys. So I should be checking it under the index. So under the index, we see a unique index is there. This index basically enforces the uniqueness on that particular column, database version. And I've specified that index using the filter criteria. It is only applicable to rows that are not null, and those should be unique. It will allow any of the null rows. On the null rows, this index is not applicable, and it is applicable only for the rows where we have values for the database version, and it will ensure that those values should be unique. So guys, we are done with this demo as well. We are done till demo 5. Now let me come to demo 6, where I will show you how you can modify a unique constraint by using the SQL Server Management Studio. So let me take you through this demo. So you can modify a unique constraint in SQL Server by using the SQL Server Management Studio or Transact-SQL. So I will cover the demo 6 and 7 here. So let me show you how you can do that. Earlier we had created an index on the check table, unique index on the check table column. So this is the unique index I had created on column 2. So let me show you how you can modify that. So you need to be in the Object Explorer. You need to right click on the, let me close this query windows quickly. All right, I don't want to save it. And you need to right click on the table containing the unique constraint and select the design mode. And on the table designer menu, you need to click on the index keys. This will open up the index keys box. And in the index keys dialog box under the select primary unique key section or index, select the constraint you wish to edit or modify. And we can complete from the following actions. Let me describe those. So first action is we can change the column that the constraint is associated with. So here it is associated with column 2 right now. If we want to change it to get applied to the column 1, we can change it over here. So this is how you modify. And second thing you can change is you can rename the constraint. So you can change the name of the constraint over here. And we can also set the clustered option. So created clustered. Right now it is no. So we can change it to yes. So basically, if we select yes for clustered, it will create a cluster index. So select create as clustered from the drop down menu. Choose yes to create a cluster index and no to create a non-cluster one. So if no is selected, it will create a non-cluster index, and if we set it to yes, it will create a cluster index in the background. And please be sure that only one cluster index is supported per table. So make sure that there are no already existing cluster indexes on the table. In our case, that there are no cluster indexes already exist on the table. And if there are cluster indexes, yeah, you cannot mark it as yes if there are already existing cluster indexes. So let's keep it at no for now. And we can define a fill factor for fill specification. We can give it over here. We can define the fill factor for the index, and the value can be between the 0 and 100 for the index pages fill factor. If you want to learn more about fill factor, you can watch out my videos on indexing where I had discussed upon this fill factor thing. What is a fill factor? So basically this setting specify how much your index pages will get filled, like 80% before a new index page gets created. All right, so after making the modifications so far, we are just changing the column on which the unique constraint is applicable. Let's click on close. Let's close this and save this. So this is how you modify unique constraint using the SQL Server Management Studio. The other way is you use Transact-SQL. So if you want to use Transact-SQL, you must first delete the existing unique constraint. So in order to delete the constraint, you need to drop the constraint. So in order to drop the constraint, you need to specify drop constraint. So you need to first alter table, and the table name is check table. And then you need to issue the drop constraint statement and specify the name of the constraint, which is ix underscore check table is the name of the constraint. So if you execute this statement, this constraint will get deleted. So if you want to modify a constraint using Transact-SQL, first you need to drop this constraint, and you need to specify a new constraint from scratch, which we had performed during the earlier practicals like demo 1 and demo 2, where I had shown you how you can create a constraint from scratch. All right, so we are done with demo 6 and 7. Let me close this. I'm not deleting a constraint here, but I've just given you information how you can do that. You need to delete the existing constraint if you are using Transact-SQL and create a new constraint altogether from scratch. Let's discuss on how you can delete the unique constraints. Let me see how many demos it will cover. So demo 8, demo 9, demo 10. These three demos will get covered for deletion. And let's dive into that. So to delete a unique constraint using the objective, so we are in the keys area of this check table. If you want to delete the constraint using the object XO, you can right click on it and simply select delete. And in the delete, this will open up a delete object dialog box. Verify the correct key is specified and we can click on OK. So if you click on delete, it will open delete object dialog box. If you click OK, it will delete this particular constraint. So one way is this. And we can also delete the constraint by using a table designer. So we can open a table in the design view, right? And we can open from the table design menu, we can select index keys. And in the index keys dialog box, we can delete this particular key from here, index key from here. So this is also one of the way. So once you delete that, just close the box, close the table, and if it asks you to save the table, just save the table. It will remove the indexing key or unique constraint. Your unique constraint will get removed from the table. Now let me show you how you can perform the same using the Transact-SQL statement. So first of all, if you want to check what all unique constraints are there, you can check that as well. So let's trigger a new query. Let's do a select star from this sys objects.system catalog view, sys.objects, and let's filter it out where we are taking a type as The unique indexes have type UQ, which indicates a unique index. And second criteria I'm taking is I want to take the object name. Object name, and we are passing the parent object ID. So parent object ID will be the table, right? And we are comparing the passing the parent object ID to get its object name, and the parent object ID will be the table. So in our case, let's take table name as check table. Check TBL is the table name. Let's execute this statement to see if we have such index. So we have this index, right? It has given me this index. Name is there, and it's a unique constraint. This is a unique constraint, and this is the way to get the information about any of the unique constraints defined on the table. Now let me just drop this constraint. So I need to alter the table, which is check table, and we simply need to drop the constraint using the drop constraint statement, and we can specify the name of the constraint. In our case, it's ix underscore check table. So let's drop this constraint. Constraint is dropped, and if I check it now, I will not get anything. And if we refresh the key section, this will go away. Let's refresh. So the constraint is now removed from the system. So guys, we are done with all these three demos where I've shown you how you can delete a unique constraint using Object Explorer, how to delete a constraint using the table designer, and how to delete a unique constraint using the T-SQL statements. All right, now let's move on to check constraints. So I will first show you how you can create a check constraint using SQL Server Management Studio, and how you can create a check constraint using the Transact-SQL statements. Alright guys, you can create a check constraint in a table to specify the data values that are acceptable in one or more columns in SQL Server by using the SQL Server Management Studio or Transact-SQL. So earlier we had discussed about the check constraint. Now let me show you how you can create a check constraint using the SQL Server Management Studio. So let's take this table in this case. Let's see if it has any rows. Right now it doesn't have any. Now in the Object Explorer, expand the table to which you want to add the check constraint. Right click constraint and select new constraint. So first of all, you need to expand the table. So there's a constraint section where you define the constraints, right? So in that constraint section, there's a check row count constraints already defined. Although I've removed the key, I should also have removed this constraint. So maybe I need to refresh it. It is not removed. The constraint is already there. It is not removed. Although the key which was applying this constraint to the column 2 was removed, but the actual constraint was not removed. The constraint definition was not removed, right? So let me remove that as well. So I don't need this constraint. So let's remove that. All right. So we have expanded the table, check table, and to which we want to add the check constraint. So we need to right click on the constraint section and select a new constraint to define a new constraint over here. In the check constraint dialog box, select it opens up a check constraint dialog box, right? So it has already showing me a new check constraint name, right? Now in the check constraint expression dialog box, so this is the expression dialog box. You need to type the SQL expression for the check constraint. So we can apply a check constraint to limit a number of values in column 2 maybe of this particular table, check table. We can limit the values that can be entered in the column 2, this table, to a value that is either greater than or equal to 10 maybe you can take, or is a null value type. So nulls are also accepted. Those are not checked for check constraint. So we can define the SQL as maybe I can take call to should be greater than equal to 10. So anything equal to 10 or greater than 10 should be added here. Not anything less than 10 should be added to the column. So this is our check constraint. All right. So once you define that expression, and there are another options as well. Should it check the existing data on creation or renaming? We have set it to yes. So right now there is no data on the table, and we have enabled and we are enforcing this constraint on any of the insert or updates, and we are also making sure that it gets replicated if replication is set up on our system, or if this table is being replicated to another server. Let's close this and save the table structure. Now if we take a look at the constraint section, if we refresh it, we will see this constraint, which is a constraint on column 2, table, right? So let's trigger a new query quickly and let's try to insert the value that invalidates the constraint. So insert into, let's give the table name. So table name is check table and the column is, let's take both the columns. So let's take column 1 and column 2, right? And I'm inserting the values. Let's take 10 for the first column. And on first column, the check constraint is not defined. It is only defined for the second column. So let's put a value 9, which invalidates the constraint basically. Let's execute this statement. It should give us an error message. So you see this message, the insert statement conflicted with the check constraint. So this is invalidating this check constraint. So the value should be greater than equal to 10 if we want to insert this row into the table. So let me change it to 12. Now it should be able to insert these values into the table. So this is now executed successfully and we can select the data from the table. If we do a select star from check table, we see that this row is inserted. So we have this row inserted. So the second column does not accept anything less than 10. And we have seen the situation where it does not allow these type of entries to be inserted, where the values are less than 10 for column 2. All right. So we have verified that. Now let me show you how you can create a check constraint using the Transact-SQL statement. Let me close this SQL scripts. Now let me just drop this check constraint. So if you want to delete it, you can right click it and just do a delete here. So check constraint does not create any indexes, whereas the unique constraint does create the unique index in the background. So let me remove this check constraint. Let's just simply delete it. And let me show you how you can use the Transact-SQL to add a constraint to an existing table. In this case, we will use the check table. If we want to add a constraint to an existing table, we need to alter that table. So alter table, and in our case, check table is being altered. Let's add a column 3. Let me add column 3. And this is of integer type. And this column accepts null. And let me define a constraint on this column. And the constraint name will be check call 3. And we can get the table name check table. So this is the name of the constraint. And what we are checking under this constraint is, let's define the check criteria. We can give the check criteria under the brackets. So in order to define the check constraint, we specify the check keyword, and under the bracket we can give its definition. So let's see if we want the column 3 values should be uh, between 50 and 60. So let's take greater than equal to 50, and we can specify the AND criteria, and we can specify column 3 value should be between 50 and 60. So this is the criteria we have specified. So this is the way to add a new column with a constraint to an existing table. So let's execute this. So constraint is now added. We can refresh this section. So now we can see that this constraint for column 3 is added, where the value for column 3 should be between the 50 to 60. Let me insert into this table now to validate this constraint, whether it's working or not. So let me insert into check table. Let's take column 1, column 2, and column 3, right? So column 2 now does not have any constraints. So only column 3 has constraints. So let me add the values. Let's take 10, 10. And column 3 values can only be between 50 and 60. So we cannot take 70 here, right? So if we execute this statement, this statement will violate the check constraint. So it should not allow us to add this row. So I executed this statement. I got the error message. The statement conflicted with the check constraint. It is giving the name of the constraint. And the conflict occurred in the database and table this, column this. So this is the statement showing that the check constraint has been violated. And if we change the value, if we make it as 55, it should allow that value to enter. So the value is now entered. So this is how you add the constraint to a new column while altering the table definition, right, using the Transact-SQL statements. So guys, we are done with this demo as well, demo 11 and demo 12. Now I will show you how you can modify the check constraint using the SQL Server Management Studio and how you can modify the check constraint using the Transact-SQL statement. So you can modify the check constraint in SQL Server by using the SQL Server Management Studio or Transact-SQL when you want to change the constraint expression. So why do we modify the check constraint? We modify in case we want to change the constraint expression or the options that enable or disable the constraint for specific conditions. All right, so let me show you in the SQL Server Management. So let's close that. So right now we have only one constraint defined on this table. So if you want to modify a constraint in SQL Server Management Studio, what you need to do, you need to right click on the table containing the check constraint and you need to go into the design view of that table. And on the table designer menu, you need to select the check constraint option. So which will basically gives us the check constraint box, giving the list of check constraints. Now, right now we have only one check constraint on this table, and column expression is this, right? We can change this column expression over here, and we can change the name over here. And apart from that, we can set these options as well if we want to apply the change constraint on the existing data on creation or re-enabling. And we can enforce this for any insert and future insert and updates, and we can enforce it for application as well, so that this constraint gets replicated as well, so that it can be applied by the subscriber systems as well. All right, so let me make a change. So let me make a little change to this constraint to apply, take any values between 45 and 60 for column 3, which is a list of acceptable value. Close this and save the table to update this constraint. Now, this is the way you can update this constraint using the SQL Server Management Studio. If you want to perform the same operation using the Transact-SQL, what you need to do is you must first drop the existing constraint, which is this constraint, and then you need to recreate it from scratch. We had shown you in earlier demos how you can create a check constraint. So you need to drop a constraint and you need to create a new constraint altogether if you want to modify a constraint using the Transact-SQL statement. Now let's go into demo 15 and 16, where I will show you how you can delete a check constraint using the SQL Server Management Studio and how you can delete it using the Transact-SQL statement. You can delete check constraint in SQL Server by using the SQL Server Management Studio or Transact-SQL. And deleting check constraint basically removes the limitation on data values that are accepted in a particular column. For example, if we delete this constraint, it will access the limitation that we have on the values that can be entered into column 3 if we remove this constraint. And let me show you how you can quickly delete the constraint using the SQL Server Management Studio. So if you want to use the GUI mode in SQL Server Management Studio, you need to expand the table where the constraint is there. Expand the table, expand the constraint section, locate the constraint which you want to delete. Right click on that constraint and select delete to delete that constraint. When you click on delete, a delete object dialog box will open. If you click OK, the constraint will get deleted. Right now I don't want to delete, so let's click on cancel. And let me show you how you can use the Transact-SQL statement to drop this constraint or delete this constraint. So in order to drop the constraint, you need to alter the table on which this constraint is defined. In my case, it's defined on the check table. And you need to use the drop constraint statement to drop this constraint. And you need to specify the name of the constraint, which is check column 3 underscore check table. All right. So execute this statement to drop this constraint or delete this constraint. So this is executed. And if we refresh the constraint section, this is now removed from the constraint section. So guys, we are done with these two demos as well, demo 15 and 16, where I've shown you how you can delete the check constraint using the SQL Server Management Studio and how you can do the same stuff using the Transact-SQL. Now let me show you how you can disable the check constraint for application using SSMS and T-SQL. All right, so I've dropped a check constraint. So let me again redefine the check constraint so that I will show you its how you can disable a replication for a check constraint. Let me create a check constraint quickly. So let me alter this table, alter table, check table. So let's add a constraint to column 3, and the name of the constraint will be check call 3. Let's give the table name check table, and this will be a check constraint mentioned by the check statement, and give the body of the check constraint and specify the expression. So we can say that column 3 should be greater than equal to 45, and column 3 should be less than equal to 60. So it can accept values of between 45 and 60. Let's add this check constraint. Now the constraint is added, and if we refresh the section, we will see this constraint. All right. Now let me show you how you can disable the replication for a check constraint. You can disable the replication of this check constraint if the replication is set up. In our system, replication is not set up, but yeah, still I can show you the setting with which you can disable the replication of this check constraint to all the subscriber systems. Now you can disable check constraints in SQL Server by using the SQL Server Management Studio or Transact-SQL. And we can also explicitly disable check constraint for replication, which can be useful if you are publishing data from the previous version of SQL Server. Now, if a table is published, so basically we publish tables if we are using the replication. So if a table is published using the replication, check constraints are automatically disabled. So if replication is being used, the check constraints are automatically disabled for operations performed by replication agent. So they are not replicated by default. And when a replication agent performs an insert, update, or delete at the subscriber end, the constraint is not checked. But if a user performs then insert, update, or delete, the constraint is being checked. So these are the two criteria at the subscriber end. So any insert, update, or deletes are checked at the publisher level, but not at the subscriber level. Now the constraint is disabled for the replication agent because the constraint was already checked at the publisher when the data was originally inserted, updated, or deleted. So if we enable the replication for this table, that replication of this check constraint automatically gets disabled. All right. And let me show you how you can explicitly disable the replication of this constraint. So you need to right click on that. So basically what you can do is you can expand the table with the check constraint that you want to modify, and then expand the constraint folders to locate the constraint you want to modify. Now you need to right click on that constraint, check constraint, which you wish to modify, and click on the modify button to modify that constraint. It will open up a check constraint dialog box, and under the table designer, select the value no for the replication. So third option is there. In force for replication, you should set it to no, and click on close the structure of the table. So right now the replication for this check constraint is now disabled. Now if the replication is set up, this constraint will not get replicated at the subscriber system. Now let me show you how you can use the same stuff using the Transact-SQL statement. Let me first modify it using the GUI mode and set it to yes, set the replication to yes. And I will disable it using the Transact-SQL statement. So let me save this table quickly. Now let's execute some SQL statements to disable this, disable the replication of this constraint. So to disable the check constraint for replication, we need to connect to the instance of the database engine. We need to open up a new query. So in order to make any changes to constraint, we need to drop an existing constraint and define a new constraint altogether. You need to run the following statement. So we need to alter the table. In our case, it's check table. So we want to modify the constraint. We need to drop the constraint altogether. So just drop the constraint. Give the constraint name. The constraint name is check underscore call 3 underscore check table is the constraint name. So first we will drop the constraint from the table. Then we will again alter the table and create a new constraint under that table. So give the table name. We are altering and we are adding a brand new constraint with the same name. We can copy out the name from here. All right. After defining the name of the constraint, you can specify that this is a check constraint, and you can specify the condition that it is not for replication. So you can specify not for replication clause if you want to mark it as not for replication. And then you specify the body structure where you can specify that column 3 should be greater than equal to 45 and column 3 value should be less than equal to 60. So this is the body of the evaluation expression, which makes this constraint to get triggered or not. So constraint will get triggered. It will check for the values between 45 and 60. These are the list of valid values range. If anything outside of that, insert or update operation will fail. And here we are marking as this constraint. This is not for application. We are explicitly marking that. So let's execute both of these statements. So these are completed. Now we can refresh the constraint section and check the constraint properties by modifying it. And now we can see that enforce for application is set to no. And this can be done by using this not for application clause while adding the constraint to the table. So guys, we are done with this demo as well. And we are done with demo 17 and 18. Now let's go through demo 19 and 20, where I will show you how you can disable the check constraint with insert and update statements using SQL Server Management Studio. So if you want to disable the constraint for any of the updates and inserts, you can do that as well. You can disable a check constraint for any insert and update transactions in SQL Server by using the SQL Server Management Studio or Transact-SQL. And after you disable this check constraint, future inserts or updates to this column will not be validated against the constraint condition. So this is if you disable this constraint, any of the future inserts or updates to this column will not be validated against any of the constraint conditions. And basically we use this option if we know that the new data will not violate the existing constraint, or if the constraint applies only to the data that already exists in the table. Only under those conditions we disable this constraint for any insert and update transactions. So let me show you the way how you can do this via the SQL Server Management Studio. So we take a look at this table. We have this check constraint, right? Let's modify it. And basically to disable it for any future insert and update, we can select this option, enforce for insert and updates. We can set it as no. So let's set it as no. So any future inserts and updates will now not get validated against this particular constraint. Now let me again modify it and set that option back to yes. Save the table, right? Now let me show you how you can do the same stuff using that Transact-SQL. We can specify it with no check, change the statement to no check. We don't need to drop the constraint, I think. So instead of add, we can use the no check constraint and remove the statement here. Let's remove the not for application as well. So we are not checking this constraint now. And we don't have to specify the table definition. The constraint is already there. We are just modifying one of the settings and we don't need to even drop the constraint. We can just simply directly modify if we just want to change that setting. We can simply make it as no check instead of check. So let's execute this statement to see if it is modified now. Set it to no or not. Now it is set to no. All right. So this is how you can use the Transact-SQL statement to disable the constraint for any inserts and for any future inserts and updates to the table. So guys, we are done with the list of demos. We are done with 20 demos. I hope you liked the demos presented in this video and the theory discussed during the theory discussion part. We have discussed on unique constraints and check constraint and how you can manage that and what are the limitations applicable on the check and unique constraints. And finally, we have covered a list of 20 demos on how to work with these constraints. So I hope you like both the theory and practical part. If you really like this video, guys, please click on the like button below this video. And once you click on the like button, there's a subscribe button just near to it. Click on that subscribe button, select all notifications. So once you click on the subscribe button, it will give you a bell icon. If you click on bell icon, select all notifications to get notifications regarding all my future videos. And guys, do post in your comments. We really like your suggestions and feedback. So do post in your comments, feedbacks and suggestions. We eagerly wait for your comments and would love to read them. And also, guys, if you have a good network of friends And if they are also working in SQL Server domain, please share my videos with them using the share button below each and every video. We get the share button where you can use this share button to share this video with your friends on any of the social media platforms. So share my videos with your friends and also ask them to subscribe to my channel in case you feel my videos can make a difference in their life or can improve their life if they are working in SQL Server domain. Thank you so much for your time on this video today, guys, and you have a wonderful day ahead. Thank you.